Welcome to another lecture on Java. We are still looking on the JVM, and today we want to look at the runtime memory areas of the JVM, and we are going to look at the following contents under the runtime memory areas. So this is a graphical representation of the memory areas, which is a memory allocated by the JVM, and we'll look at what each memory actually does. Then the first is the method area, which is now called the meta space. So the method area, which was known previously as the permanent generation, is considered a part of the heap memory, although the simpler implementation of the JVM may choose not to garbage collect it. However, Java 8 removed the permgen and introduced a new native memory space called meta space. So a meta space is a native memory region that stores metadata for classes. As a class is loaded by the JVM, its metadata, e.g. its runtime representation in the JVM, is allocated into the meta space, and the meta space occupancy grows as more and more classes are loaded. When reflection is done, some of those frameworks, they will introspect the meta space to get the structure of that particular class they are actually trying to do reflection on. Then we have the heap. This one is a very popular memory area in the JVM, a place where object data is stored, and you can control it with the following variables: XMS, which means minimum size, XMX, which is actually maximum size, and by default the initial size of the heap is 1/4 of the physical memory of the computer. Then we also have what we call PC registers. This actually contains the program counter, which is the pointer to the next instruction to be executed. And there is one PC per thread. Then we have the stack. The stack contains the stack frame corresponding to the current method execution per thread. And each method call has a separate stack frame, as you can see. In our other video where we were talking about exceptions and the stack frame, we were able to see how the stack frame actually looks like, the representation of it. So the stack frame contains data corresponding to the current method execution, e.g. parameters, return values, local variables, the operand stack. The operand stack is an area for performing operations specified in a method. Then we have the native method stack. Supposing one of the threads has a call to a native method written in another language. You can see that in DLL files or other languages specific to a platform. A native method stack will be used. Then we have what we call the StackOverflowError. The StackOverflow, if a recursive method call does not have an exit point, or it recurses infinitely. For each method call, a stack frame gets created until the stack is full, therefore resulting in a StackOverflowError. The XSS can be used to specify the size of the stack.